Hey guys, this is Naveen Raja. Welcome to Passion Vidya. So, guys, in the last topic, that is kinematics, we have discussed mathematics of motion. Like we have starting from locating a particular body, how to find the position of a body, then how does this position change. So, in that process, we have defined terms like distance, displacement, velocity, acceleration, and we found the relations between them. And using these relations, we have discussed how to estimate the position of a body after certain time, or how to find acceleration of a body at a certain time, or average speed, average acceleration. These are the things which we have discussed in detail. So in this topic today, we will be dealing with dynamics of motion. So actually, before going into what actually dynamics of motion is, what we discuss in this topic, so let us recall what is motion and rest actually. So let us recall it. We already discussed this in our kinematics, or motion in one dimension, but now let us recall it a little bit. So in physics, uh, rest means a body is said to be in rest when its position does not change with respect to surroundings, right? Then we call the body to be at rest. If the position of the body changes with surroundings, with respect to surroundings in a given interval of time, then we can call it as in motion. The body is said to be in motion. So now, uh, in this topic, in dynamics, or in previous topic, we didn't discuss about these two aspects, right? So when a body is actually at rest, how to move it, or how does a motion start? So we didn't discuss this part in the kinematics part. There we only analyzed about mathematics part of the motion. When the body is in motion, we discussed about the parameters involving in the motion, but we didn't discuss how the motion has started. And similarly, we didn't discuss when a body, let us say when a body is moving, how to stop it, right? So these are the two questions which we will going to tackle in this topic, that is dynamics of motion. So guys, to understand this, let us consider the situations where this is happening, means where the body is changing from rest to motion, or from motion to rest. So let us check the situations one by one. So first, if you take a football, here consider a football. So this football is initially at rest. So now, after the person kicks, or the footballer kicks the football, all right, it starts moving. It is in motion. Here it is in rest, and here it is in motion, because here the position of the ball is at constant. It is not changing with the surroundings, whereas here it is changing its position. So here it is at rest, here is it is in motion. So now, what is happening here? So how it is changing its state of motion from rest to motion? By, as a person, here you can check the person, the foot is applying a, what you can say, it is interacting with the ball, or it is pushing the ball. Here there is a push. So due to this push, right, the ball started moving, right? So let us check one more case. So in this case, let us say there is a cart, or you can say basket, vegetable basket. Now the person, right, is initially this is at rest. Now you want to move it. How do you move it? You just push it, right? Here the person is pushing. Here also you can check there is a push. So the person is pushing with it, or you can say the person is interacting with the basket. Now let us take one more case. So let us take this cart. So now this horse is moving forward, and there is a string connected between these two. Now when a horse is moving forward, the string becomes tight, and it pulls the cart. So now the cart is moving from, initially it is at rest, now it is coming into the motion. Now let us take one more case. Let us say in this case, your ball, baseball, is initially in motion. Here it is in motion, and you have to stop it. So you want to stop it. How do you stop it? How do this person stop it? So he's applying he's interacting with the ball, or the ball is coming like this. He's pushing the ball in opposite direction. So there is a push again. Here also there is a push. So the ball is being pushed by the gloves. So in the previous case, there is a pull. Here you have a pull. So let us consider all these cases. What is common in all these four cases? Everywhere there is the body, whatever body which is changing its state of motion, or which is moving from rest to motion, or motion to rest, it has to interact, or it has to interact with the other body. Here the ball is interacting with the foot of the person. Here the hands of the person are interacting with this basket, then only basket is changing its motion. Here the thread or the string connected between the horse and this cart is changing the state of motion of the cart, means it is interacting with some other bodies. Here also the hand of the person is interacting with the ball. So here what is common is the interaction of another body with that particular body is necessary, it is must, then only then it can change its state of motion. Is that clear? Here you may get a question, if you observe it properly, day to day situations, you may observe something different. So if you take this pen, if I leave it, now initially when I leave it, it is at rest. It start moving. How does this move? Here no one is interacting with it. Here no one is interacting. Then how does it move? So actually, yeah, the same question Newton got when he sat right under the apple tree. So now this apple is falling down. Now this when apple is falling, right, that no one is interacting with it. How does it motion change? Actually, to be precise, here the earth, then later he found a topic called gravitation, and a lot of concepts has developed there. So he found that actually earth is interacting with the apple. So now guys, the interaction, when I say in the four cases interaction is must, even in this case interaction is must. So the interaction, it need not be contact, it need not be the contact, physical contact, it can be non-contact interaction also, like earth and the apple, these two are interacting, but it is not a contact, they need not touch. Okay, so now we understood to change the state of motion, either from rest to motion or motion to rest, rest to motion or motion to rest, interaction of that body with surroundings is must. So interaction is necessary. What kind of interactions? If you observe the last four cases, it is either push or pull. So this push or pull or the interaction of the body with surroundings is what we call a force. So here they have defined a physical quantity as force, which is basically a push or a pull, or simply you can say it's the interaction of two different bodies. So this is actually forces. So I hope you understood what force is. So we can define force as a push or a pull that can change the state of motion, or simply a physical quantity. Basically it is a physical quantity, you can measure the force, so you can call it as a physical quantity. So it's a physical quantity that can change the state of motion, right? I hope it is clear. So what do you mean by actually state of motion? So guys, I hope you understood it, but let me check what you understood, and let us deep dive into the concept further. What do you mean by changing state of motion? Let us think. Let us just look at the previous cases where we understood that, where we thought the bodies has changed the state of motion. Here we said that ball has changed its state of motion. Here the basket has changed its state of motion. Here the cart has changed its state of motion. Here the ball has changed its state of motion. What we actually mean by change in state of motion? Just pause the video and try to think, guys. Try to get your answers. Okay, so yeah, here you might be thinking that it is change in speed, because in the first case, in all these cases, speed is obviously changing, right? So you may think that it is change in speed. What we actually mean by change in state of motion? You may think that it is a change in speed. So let us check it with some examples. So if we take two examples, let us say car is moving with a 50 meter per second and a ball is also moving with 50 meter per second. So now initially both are at same speed. Now let us say we have to stop it. Let us say final speed becomes 0 and 0. So the change in speed is same in both cases. Now if the change in speed is same, we define force as the quantity which changes the state of motion. So now means we are thinking that it is change in speed. So to change the speed by same value, you need same force. But if you observe in these two cases, right, the force or the effort, the push you need to apply on this ball to stop it, and the force you need to apply on this car, is it same? No, right? So actually the effort needed or the force needed here is different. means actually the state of motion is not just about speed, right? Yes, obviously speed changes, then only we say the motion has changed. All right, but suppose definitely what we can say that speed is associated with state of motion, but we cannot say state of motion itself is speed, because here you can check it in these two cases. Even though the speed change in speed is same, but the effort, the force needed is different. So now we can understood here, if you take two bodies of same mass, and if you change the speed by same, if to change the same speed by same value, then the effort needed, the push needed, or the force needed will be same. So from there we will understand that mass is also involved in this state of motion, changing state of motion. So now I can say state of motion is associated with both mass as well as speed. Yes, speed is obviously there, but mass is also associated with it. So now how to define it properly? Two terms are there. Now can we get into a single term? So what is the term which we have which contain both mass and speed? What is the term? Yeah, at the time, yeah, they thought that yeah, kinetic energy. You have kinetic energy, so we know kinetic energy is the term which contains both half into mass into speed, mv square. So this is the term which we have, or which is already defined at the time when they are talking, when they are discussing about this. They already defined this kinetic energy as half mv square. So now this kinetic energy contains both mass and velocity. Now, is it? Let us check. Is it state of motion means kinetic energy? Is state of motion mean or is represented by kinetic energy? Let us check it. So similar way, let us take the two bodies and change its kinetic energy and check the effort needed or the force needed. Is it same or not? From there we will understand whether state of motion is representing kinetic energy or not. Now the question is it changing kinetic energy? State of motion. What do you mean by changing state of motion? So now if you look at the same example, let us take the previous example. So in this example, so let us say we have stopped it. So change in kinetic energy here, change in kinetic energy is a minus half into 500 into v square 50 square. So this is the change in kinetic energy of the first body. Similarly, change in kinetic in the second body, 0 minus half into 1 into 50 square. So now if you look at the change in kinetic energy of the first body and the second body, if you find the ratio of it, it is 500 times. So the change in kinetic energy of car is 500 times the change in kinetic energy of the ball. So now if you look at the effort needed or the push needed, it is approximately, or it is almost exactly 500 times. So from this example it is appearing like state of motion or the force is associated with changing kinetic energy. Guys, if you look at this properly from these examples, this is satisfying. But let us consider one more example. I'll try to take another example, whether it is satisfying there or not. So check it. If you take a ball here, if you take a football here, so it is actually traveling towards east, let us say 50 meter per hour. Now you want to change its direction. If you want to change its motion, or if you want to change the 50 kilometer per hour in vertical direction. So let us say, if you check the kinetic energy of both bodies, here the kinetic energy is a half into m into 50 square. Here also kinetic energy is half into m into 50 square. Now the change in kinetic energy in these two cases is 0. Means if we take the force means the rate change in motion, change in kinetic energy, then in this case the kinetic energy is not changing. It means you need not apply any force to change the body which is moving from with 50 kilometer per hour towards east to 50 kilometer per hour towards north. But in real situation, or if you look at properly, actually you need force. You have to apply force to change the direction. So if you don't apply force, the direction of motion does not change, or the direction of a particular body does never changes. So means so direction is also associated with our motion, right? State of motion means now state of motion is associated with mass, speed and direction. So now the speed and direction together we can call it as a velocity. We know it, we discussed in kinematics. So now state of motion is associated with both mass and velocity, right? So now, if I look at properly, so now they have defined. So there is, at that time there is no term. So that's why. So in physics, always the terms are defined according to the usage. If you need it, then only we have to define a term. Otherwise, it will be a lot of terms which will be confusing. So now, as we cannot define state of motion just by kinetic energy or by mass or speed, we need a physical quantity to define it. So this momentum, that is mass into velocity, is the physical quantity which actually gives you the better idea about state of motion. So now momentum p bar is defined as mass into velocity, mv bar. So now guys, this is the quantity which actually gives you the idea about state of motion. So now we can define force, we can redefine force as, actually we understood force is a physical quantity which change the state of motion, right? So now we can redefine force as the physical quantity that can change the momentum. So this is how we can understand it. So guys, here I'm not just giving you the formulas, or I'm not just giving you the expressions or definitions. So we are trying to understand it. So try to feel the topic and try to involve in the topic. So here the force is a physical quantity which can change the momentum, right? I hope you understood what is force. So a force is a physical quantity that can change the momentum. Now, what you mean by, so let us think further. So I want to take you more deeper into the topic. What do you actually mean by changing the momentum? How do you change the momentum? What do you mean by changing momentum? How to change the momentum? Yes, you apply force, right? Force is a physical quantity that changes the momentum. So now changing the momentum means what you are changing actually there. So we know momentum is equals to, we defined it already. Momentum is equals to p bar is equals to mass into velocity. Now in this we have mass and velocity. Now you may change the mass or you may change the velocity. But in our day-to-day life, if you see it properly, in all the cases, previous cases which we discussed, there the mass is constant. Mass is constant in all the cases. That's why we can directly say changing the motion means, we assume that, or it appears that change in motion means change in velocity. That is only for constant masses. But if you take some other masses where mass is continuously changing, some other bodies like a rocket, let us take an example, rocket. So there the rocket continuously releases the gases. So now these gases, when it releases gases, mass of the rocket is continuously decreasing. So in that case, the change in motion is not directly proportional, or not exactly as a change in velocity. So now if you look into this change in momentum in a different aspect, like a momentum has two quantities, like it is a vector quantity, so it has two aspects, magnitude as well as direction. So now when you change the momentum, you can change the magnitude or you may change the direction as well. So let us check it, when the direction change and when does the magnitude change. So if I look at it properly, if you take a body which is moving towards east, let's say, if I push in the same direction, if I further push it, what happens? Its speed increases, right? And if I push it in opposite direction, its speed decreases. So if I apply force in the direction of motion, right, either in the forward direction or backward direction, its magnitude of the speed or magnitude of momentum increases or decreases. Magnitude changes, but the direction, does it change? It does not change, right? So when the force is applied parallel to the direction of motion, its momentum, magnitude of the momentum changes, but direction does not change. Similarly, when a body is moving towards east, if you apply, if a sudden force, if you give it towards perpendicular to it, then its direction changes, right? Direction changes, but speed does not change there. So when force is applied perpendicular to the line of motion, it changes its direction. So the body here, it moves like this. It deviates from the path. Okay. Now, in case if the force is at a certain angle, if you have a force like this, so now the direction of motion is in this direction. Now if we apply the force at certain angle theta, now both direction as well as magnitude changes. Now for that we will take two components, that is a parallel component, we call it as tangential force, and the perpendicular component, we can take a components for forces. So this is a radial force or a normal force. Radial force or normal force. So this tangential force changes this tangential force changes the direction or magnitude, sorry, changes the magnitude of momentum p bar, whereas normal force or radial force changes the direction of motion of p bar. So this is how we can understand. So what is a force? Basically, force is a physical quantity which changes the momentum. How does it change? When you apply the force parallel to the momentum, it changes its speed, or you can say it changes its magnitude. And if you apply force perpendicular to the direction of motion or direction of momentum, then it changes the direction of momentum. All right. And if you change at certain angle, then you can take two components for it. It will have both the components. It has a component along the direction of motion. We call it as tangential force, and the component of force perpendicular to the direction of motion. It's called a radial force or radial component. A radial component changes the direction. So radial component is responsible for changing direction. Tangential component is responsible for change in magnitude. So this is how we can understand a force. I hope you got a better idea about what actually a force is and how motion changes. So force is a physical quantity which changes the motion. So now let us further discuss it. Before further discussing it, actually in our nature or in day-to-day life or in our nature universe, we have several forces. There are infinite number of forces, like hand force applied by hand on hand, lot of forces. But all the forces, normal reaction, friction, tension, so there are several forces. All these forces can be categorized into four basic categories. They're actually basically there are four fundamental forces. So that is electromagnetic force, gravitational force, strong nuclear forces, and weak nuclear forces. So these are the four different types of forces. So actually you will come across these nuclear forces in a later topic, so I'm not going into that aspect right now. So electromagnetic force, basically this is the most commonly we come across the forces is electromagnetic force, like all contact forces like normal reaction, friction, tension, everything comes under electromagnetic force. So guys, we will be discussing detailed way after in the next topic, next class, about these all contact forces, how they are developed and what is the reasons behind it. So now if you look at it, these are the four basic forces in nature. So electromagnetic force, gravitational force, strong nuclear force, weak nuclear. And if you check out the order of the forces, so out of all these four basic forces, the strong nuclear forces are strong nuclear forces are the strongest, and then followed by electromagnetic force, and then weak nuclear forces, and then the weakest force is gravitation. So that's it, guys.